Not all datasets are prepared for data analysis, and it will require that you do some data manipulation tasks that involve things such as cleaning, structuring, as well as creating additional data columns. This will require that you wrangle with the data to get it tidy and ready for data analysis. Depending on the dataset or datasets, manipulating data involves many pandas, attributes, functions, and methods. Here's a list of what will be demonstrated in the coming slides. You may come across a dataset that has a wide data structure, where every column is not a variable. This is a typical way that some organizations collect data, especially time series related data. A wide data structure is typically reshaped into a long data structure for the purpose of data analysis. To convert wide data to long data, we could use the pandas melt function. Let's take a look at an example. Throughout this video, we'll be examining COVID-19 data from Johns Hopkins University. Since this is a dataset that's available online and in CSV format, we could use the pandas read_CSV function. There are two datasets that will be used. One dataset is related to the total reported cases per day, and the other one is related to the total reported deaths per day. Both datasets are stored in their respective data frame variables. Looking at the first 5 rows for each of the datasets, we can get an idea of the data that's involved. Due to space, it is not possible to display all of the columns, so this is a wide data structure that we need to convert into a long data structure for data analysis. Here's a snapshot of the reported cases data frame in Microsoft Excel. Since it is not possible to see all the data columns because of its structure, you'll notice in column L onwards, each column is a date of which COVID-19 data was reported for each county in the United States. For this example, we'll focus only on Virginia data, so we'll need to do some subsetting. The province_state data column contains the categorical data related to all the states. The subsetting will be performed on both the reported cases and reported deaths data frames. This is shown in line 1 in both cells. Line 2 uses the drop method to remove the data columns that will not be used for analysis. The drop method takes a list argument that contains a list of column names as strings that will be removed. The access equals 1 lets the function know that we are removing columns. You could remove rows if you needed to by entering a 0 argument instead of 1. The in_place equals 2 is so that the change can be made directly into the data frame and permanently. Here is the Python documentation related to the drop method. The labels parameter, access parameter, and in_place parameters were used in the previous slide. The rest of the parameters were left as is. After doing some preliminary cleaning steps on both datasets by dropping and renaming the columns, the melt function can be applied to reshape the wide data to long data. There is no in_place parameter, so these changes will need to be assigned to another variable. The melt function is difficult to explain and is better understood through illustration. The wide data structure contains mostly columns with dates and reported numbers for each date. The color-coded boxes show you the relationship between each cell to convert from wide data to long data. Focusing on the melt function, the first positional argument is the data frame itself. This is the data frame that needs to be melted or reshaped. The next one is a keyword argument, id_vars, which is assigned a list of the column names that are not to be reshaped and to stay as it is. The var_name parameter will be assigned the column label for the new reshaped data. And this is going to be the column that will store the wide data column labels inside of it. The last keyword argument, assigned to value_name, will be the new column label that will contain all the values related to the wide column labels. Recall that both datasets contained hundreds of data columns within the dataset, whereas now it has narrowed down to 5 columns for the confirmed cases dataset and 6 columns for the reported deaths dataset. Because of space limitations, the deaths dataset will not be shown here. Here's the pandas documentation that's related to the melt function. You might come across a different way to melt a data frame. There really isn't much of a difference between the alternative method and what was shown in the previous slide. The two different ways are shown here using the reported cases dataset. Lines 2 through 4 was demonstrated earlier and uses the melt function, whereas lines 7 through 9 makes use of the melt method. Pandas has many ways to combine datasets. One way to join multiple data frames together is through the use of the merge function. Which arguments to pass depends on how the datasets need to be joined. There's a lot of information to review for this function, but the example that will follow should provide some clarity on how to use this. To put things in simple terms, the datasets that need to be joined together must have at least one common key, such as the index or a data column. Let's see an example of how this works. The two data frames presented here have a few common data columns. The goal is to have one data frame to combine the reported cases and reported deaths data frames together. The data columns that are not in common are highlighted in blue. The first cell shows the merge function being assigned to a new variable df_va_merged. The merge function has two positional arguments, which represent the two data frames to merge. The how parameter is assigned the argument value left, meaning to match the common columns from the va_deaths melt data frame to the va_cases melt data frame, which is the first positional argument in the function. The result of the merge function is shown here, which now shows one data frame that contains not only the reported cases, but also the reported deaths, as well as the population, making it easier for data analysis. Just like with the melt function, the merge function could be coded a little differently. The two ways are shown here. Lines 2 and 3 are what was shown previously. This makes use of the merge as a function, and lines 5 through 9 uses the merge as a method. More code is involved with the second example, but will yield the same result. The melt method requires a little more code and uses different keyword arguments. Both of these examples can fit all the code in one line, but makes it difficult to view. Continuing on with the cleaning process, there will be instances where the column name or names in the data frame are difficult to reference when coding, so you could rename the columns using the rename method. Let's rename some of the columns related to the COVID example. The columns attribute is used to first see the column names in the df_va_merge data frame. Then it makes use of the rename method in the next cell, where it takes a dictionary argument to the columns parameter. There are different ways that you can filter data within Pandas. One way is using the query method. The documentation here shows that this method requires an argument that is expressed using a string type format. To query specific data from the df_va_merge data frame, to include only Virginia data with cases greater than 0, it can be coded as shown in line 1. Now, this data frame already contains Virginia data, but it's included here just to demonstrate the point that a query method can be used for multiple conditions. The same thing can be done with using traditional subsetting as shown here, but requires a little bit more code and must be assigned to a variable, whereas the query method contains an in-place parameter to make the permanent change within the data frame itself, instead of assigning it to a new variable. In the example you see here, the copy method is chained last so that the filtered data assigned to df_va contains a new copy of the data frame rather than a reference of the data frame. Doing this will avoid any sort of warnings or errors when it comes down to manipulating data on this new data frame variable. The isin method is useful when there are multiple values to include as part of your filter. The code cell example here uses the isin method to filter data so that it only includes observations related to Arlington County and Fairfax County. According to the documentation related to the is method, the argument passed inside must be an iterable, series, data frame, or a dictionary. So if we were only interested in filtering just Fairfax data, then it would still need to be included within square bracket notations as a list format. Dealing with time series data requires that the variable related to time is in the proper data type. To convert a variable to a datetime object, we use the pandas to_datetime function. In this example, the dtypes attribute is applied to the df_va data frame to examine the columns and what kind of data type each column has. The second cell uses the datetime function to convert the dates variable to its proper data type. The third cell shows the dtypes attribute being applied back to the df_va data frame to make sure that the change was reflected. Variables or objects that contain datetime data types can do operations and use built-in functions. For example, here we have the min and max functions applied to the dates variable from the COVID data frame. Using the min and max function on a dates variable that is not in a datetime format will yield incorrect results. Datetime objects can do math operations such as subtracting the maximum date and the minimum date. The result in this example is shown to be 224 days. To put things into context, it's been 224 days since the first outbreak of COVID-19 cases in Virginia, based off of this data frame df_va. The result of the calculation between the max date and the min date is a time delta data type. Taking this a step further, a new data column is created and called VA or outbreak, which will contain the number of days into the outbreak of COVID-19 in Virginia. The first known case in Virginia is March 8th, 2020, and this was found on the previous slide when using the min function. March 8th is considered to be day 0. This date will be subtracted from each recorded date in a data set, where the result will be stored inside the data column VA_outbreak for each respective row. The last column in the output shown here shows that October 18th, 2020 represents 224 days into the outbreak in Virginia. The creation of a new data column and creating data from existing data within the data set is called derived data. The diff method is another way to generate derived data. The diff method calculates the difference between rows or columns in a data frame. To illustrate this method, the df_va data frame is used to subset Fairfax data and is assigned to a new variable called df_Fairfax. The Fairfax data frame uses the def method on the cases column and assigns the result to a new column called new_cases. To be clear, the cases data column represents the total number of reported COVID-19 cases per date. By applying this method on the cases data column, the total cases in time 2 will be subtracted from the total cases in time 1. And the difference is the new COVID cases reported per date, rather than the total number of COVID cases recorded to date. The result of the diff method can be seen on the last column. Keep in mind that the output is just displaying the tell method, so we're only looking at the 5 last records of the df_Fairfax data frame. The derived data could be used for different analyses and plotting. This example uses the matplotlibs barplot function that outputs the new reported cases in Fairfax over the last 10 days in the data set by using the iloc attribute. The bar plot on the right makes use of the original data column cases that represents the total number of cases per date over the last 10 days of this data set. The percent change method is relatively similar to the diff method, but will result in a percent change between 2 time periods. Let's take a look at an example using the Fairfax data frame. In line 2, the code is used to generate the derived data column named cases_%_change. Then the head method is used on the data frame to view the first 5 rows. The output shows the derived data column on the far right, and the numerical values represent the percent but in decimal format. Taking a look at the first row, last 2 columns, there are 2 values that are labeled NaN, which means that there is not a number within that particular row. Handling nans is necessary, especially when there are many of them, but this is beyond the scope of this module, and we'll just leave them there for now. Using the derived data column that consists of the percent change of total cases in Fairfax, we can plot a time series graph to show the volatility of the total cases over time, starting from day 0 to the most recent time period in the data frame. Line 1 uses matplotlib's function to plot the line chart. The second argument uses the derived data column, and it uses broadcasting approach to multiply the decimal by 100 to reflect percentages on the graph. Recall that the percent change column that was generated produces the result in decimal format. One last example of creating derived data columns is using the apply method. This method takes a function as an argument that could read or manipulate each element in a data column. To demonstrate, we'll make use of Virginia's data frame, which contains several columns. Using the nUnique method on the data frame provides some insight to the unique or distinct values in each data column. There are 134 different counties in this data frame. Here is a subset sample examining the county and population columns. Based on the county's population size, let's say we want to create some categories based on population density. This can be done using the apply method. Let's take a look. So after examining the data, it may be a good idea to divide the counties based on population size for maybe some further analysis. So for example, the counties where the population is at least 1 million, then we can categorize that as high for high density. Populations that contain 500,000 up to 999,000 would be considered medium or medium density, and so on. The user-defined function shown here can be used and applied on the data column within the data frame. Once the user-defined function is created, we could use the apply method, as shown here in this example. Specifically, the county size function is included in the apply method without parentheses. The user-defined function will iterate through each row in the data column, which is considered a series, and will return either the high, medium, or low category into a new data column called pop_density. The apply function contains an iterator, so no for statement is needed. The result of the apply method is shown on the last column of the output. To see some aggregate results related to the data frame, the shape attribute and the value counts method are used. Based on the 27,052 observations in this data frame, there are 225 observations related to the high category. The remaining slides make use of the COVID-19 dataset and the different data frames involved in this presentation. Review the syntax as well as its respective output.